Hi, welcome to the video on the greatest common factor. This is to be a review for Algebra 2 students. So what is a factor? Well, a factor is a value, or in the case of Algebra 2 where we work with polynomials, could be an expression that divides evenly into another without a remainder. So we're going to be talking about integers for a little bit. Let's take the integer 24. Can you think of values that divide evenly into the number 24? Well, you might start randomly thinking of them. My suggestion is that you always start low and work your way up. So let's think of some things that are factors as well as things that are not factors. So to start off, we're going to start low. And I like to start with the number 1. 1 is always a factor of something. So 1 times 24 gets you 24. Then we'll work our way up. 2 times what gets you 24? 12. So 2 and 12 are factors. 3 and 8 would then be factors, right? All of these pairs are multiplying to 24. The next factor pair would be 4 and 6. Next, we have to think about 5. Why is 5 not a factor? Because if I divided 24 by 5, I would get a remainder. So that's going to stay in our not factors list. Next on the list, we'd have 6 times 4. Now notice we already have 4 times 6 on our list, which means we're beginning to repeat pairs. Once that starts to happen, we know that we've found our entire list. So all of the numbers between 1 and 24 that aren't on this list of factors, such as 7, 13, 23, right? All of these numbers are not factors. Okay, so let's build our way up to the greatest common factor by starting with common factors. What is a common factor? Well, it's a factor that divides evenly into a set of numbers or expressions. You can't have a common factor unless you have more than one number to consider. The other thing to know is that 1 is going to be insignificant. Since 1 is a factor of anything, right? So we're not going to really pay attention to it when it's in our list. So let's take 24 and 30. That's our set of numbers. Now we already came up with the factor pairs of 24 from the previous slide. If we went through that same method for 30, we would come up with this list. So the common factors are the numbers that appear in both lists. Right? Now 1 is in both lists, but remember I said that's insignificant. So the common factors would start at 2. 3 is also something they have in common. Notice how 4 is in the list for 24, but not in the list for 30, so that would not be a common factor. The only other common factor I can see in this list is 6. So we'd have 3 common factors for the numbers 24 and 30. Let's move on to the greatest common factor. Well, that's not a huge leap from what we just talked about. The greatest common factor, otherwise known as the GCF for short, is the largest of the list of common factors that's going to divide into that set of numbers or expressions. So let's deal with some expressions this time. Now you'll notice some familiar numbers like 24 and 30. I've also added on 42, and notice the other thing is that they are expressions, right? We have x squared with that 24, an x to the 4th with the 30, and an x cubed with the 42. That's also going to play a role in the greatest common factor. I like to treat those two things as separate. The 24, the 30, and the 42, those are called coefficients. I would still find the list of factors for each of those numbers. Next, I would find the factors of that power. So x squared, I know that x times x gets me x squared, so x must be a factor, as well as x squared. For x to the 4th, x times x cubed gets me x to the 4th, and x squared times x squared gets me x to the 4th, and x to the 4th is a factor of itself. So here's our list of factors for x to the 4th. And very similarly, Here are the factors for x cubed. All right, so now we would like to find the greatest common factor. Notice that 6 is the greatest number that appears in the list of factor pairs for the coefficients. So that's going to be part of our GCF. But it's not the greatest common factor until we also consider these variables. Now, all 3 of those lists all have an x squared. They also all happen to have an x. But in this case, x squared, because it has a higher exponent, is considered the greater of those two things. So the GCF of these 3 terms would be 6x squared. All right, so let's try to find or identify the GCF of each of these expressions. Our first one's a binomial, right? 14x plus 21. Notice how this first term has an x, right? Has a variable with it, but the 21 doesn't. So we know that this GCF isn't going to have a variable as part of it. They don't have any x's in common, right? That's a way of saying it. But 14 and 21, if I wanted to list the factors of 14 and 21, 1 and 14, let's see, 2 and 7. Over here we'd have 1 and 21, 3 and 7. I think that's all we got for those. We can see that 7 is the greatest one that they have in common. So the GCF here would be 7. For the second example, we're looking at a trinomial. Notice how the first term's coefficient is 4. That's really going to limit what the GCF can be. In fact, a lot of times I like to look at that coefficient and see if it is the GCF. So is 4 a factor of 32? And is it a factor of 16? Well, indeed it is. So I know that the GCF starts with a 4. Now I'm going to consider these variables here. X squared, I know that x would be a factor, and x squared would be a factor of that. For the 32x, x would be a factor of itself. But again, this is missing, right, some variable as part of that term. So we don't have enough x's, right? There's not an x in every one of these 3 terms to say that the GCF should also have a variable. So our GCF is just 4. And then for our last expression, we have 32x cubed minus 50x. Notice that both of these now have variables, right? So good chance that we're going to have a variable as part of the GCF. Let's break down 32 into its factors. 1 times 32, 2 times 16. 3 doesn't go into 32, but 4 does, right? 4 times 8. And I think that's the end of that list. And then for x cubed, we would say x is a factor, x squared, and x cubed. And then for 50, we'd have 1 times 50, 2 times 25. 3 doesn't go in, 4 doesn't go in, but 5 goes in, right? 5 times 10. And I think that's all we're going to get out of that. And then don't forget about the x over here. That's also going to be a factor. So what is the biggest of these numbers that they have in common? Well, it looks like 2 is the biggest of the coefficients, and then x for the variable. So the GCF here would be 2x. Now let's talk about one more thing that we like to do once we identify the GCF of an expression. We like to factor it out from each expression. So I'm just going to jot down what we found, right? We found the GCF of this one was 7. The GCF of the second one was 4. And the GCF of the third one was 2x. So when we factor out a GCF, we're taking this expression and we're writing it as something times something else. The GCF is going to be one of those somethings. We need to figure out, well, what is this part going to be? 7 times what would get us 14x plus 21? Well, in this situation, we can also think of this as a division problem. If we take 14x and we divide it by 7, what do we get? We get 2x. And if we take 21 and we divide it by 7, what do we get? We get 3. So we're actually getting a binomial. Now we can't just leave this here as a multiplication sign. We want the 7 to get multiplied with this whole binomial. So I'm going to erase that little dot, not the 2x plus 3. We wanted that to be there. But I'm going to put parentheses around this so that my final answer looks like this. I also like to think of this as undistributing, right? Because if this is where we started and this is where we wound up, it kind of looks like a problem where you feel like you want to distribute, right? We did the undistributing work here. So this would be our final answer. On to the next one. We know that this would be 4 times a trinomial, right? Each of these terms is going to become something else. We're going to take each of those terms and divide them by 4. So here we would get x squared, here we would get 8x, and here we would get -4. Don't forget to go back and put that plus sign in there. Sometimes we forget about that. And same thing here. Don't forget that that was a -16. That's why we got -4, right? So my final answer is 4 times the quantity x squared plus 8x minus 4. All right, and then for our last one, our GCF is 2x, and we're factoring a binomial, so we know that's going to have 2 terms inside of there. So what happens when we take 32 and divide it by 2? Well, we get 16. What happens when we take x cubed and divide it by x? We get x squared. On to the second term. What happens when we take -50 and we divide it by 2? We get -25. What happens when we take the x, divide it by x? Well, they cancel, and that means we've done our job. Now, I do want to point out that we've followed the directions, right? It says factor out the GCF from each expression. However, this expression actually can be factored even further, but we're going to save that for another video. That's called the difference of squares there. So, right, so we factored out our GCFs, and hopefully that will help you in the future. Good luck, everybody.